Hello guys, welcome to Math with Paul Dominus, and I'm back again. Today we're going to be looking at a surface area using integration, and particularly we're looking at a scenario with along the x-axis of that case happening. So basically the surface area of something, perhaps something like this. Let me just draw a quick sketch, just so you get an idea. Something like just something, like if we have a function like this, coming like that, a function like that, coming like that. We're finding the surface area. We're finding the surface area of like those functions, intertwined along with respect to the x-axis. So that's what we're doing, that's basically what we're doing in this case. But in this case, we're using integration. So now this is our calculus, by the way. So yeah, finding area using integration. We have a general formula there, where we have A is being the surface area, B equals to the integral holding B and A of 2 pi y being the function y ds. ds being the general formula for arc length, which is a root plus, 1 plus dy over dx squared along the x-axis. By the way, this is a scenario along the x-axis. So where it's along the x-axis, we have a y there within the integral. Where it's along the y-axis, we have an x there on the integral. So you make sure that that's also an important fact. But you can look more into that, and then you'll be able to confirm that. But in this case, we just look at y, along the x-axis. That's why we have that y over there. So yeah, and ds basically is our arc length. We have to use like some sort of length or unit in order for us to find the area at one point, right? Because this is basically multiplication. Area is length times width times something, right? So this is basically that same formula. So in this case, we have that 2 pi meaning a revolution twice in radians, and that we mean the function, and that being the arc length of the function. So basically, we're just trying to get the integral of that, and that will give us a surface area. So let's try to figure that out. I hope that makes sense. So in our exercise, it says find surface area of the function. We have a function here, y being equals to x cubed over 9 along x-axis, just like our scenario over here. We have our points there, 0, x, 2. So we're basically going to put that to, oh my goodness, what did I do? So sorry. That should be a 2, and this should be a 0. Yeah, so we put our 2 from there, over there, and we put our 0 over there. And then now we express everything. Now we have our 2 pi remaining there. We put our y function, which is that, right? This is with respect to the general function of the surface, area. I hope this is making sense. We put the x cubed over 9 because that's our y function over there, and then we just basically put in the arc length of value, where we have 1 plus dy over dx squared. So now our first task is to find dy over dx and square it and place it there to see how everything works from there. So this is what's going to happen. Now we find dy over dx of this function y. So we have y dash being equals to, sorry, let me just write y equals to x cubed over 9. That means y dash will now be 3x squared over 9. And then that will basically give us x squared over 3. So that's our dy over dx, x squared over 3. So now we have to square that in order to find in order to get to that, right? So we're just basically going to square dy over dx. Sorry, dy over dx squared will basically be x squared over 3 squared, right? Which means both of these square. Then we're going to end up with x to the power 4 over 9. And this is that value. Sorry, where is it? Yeah, that value. that is that value. So now we could, things are easier now. Now we can, you know, work much better now from this point. So now we just basically have to put that over there, and then now let's see how it goes. We had this a equals to 2, 0, 2 pi x cubed over 9, and then now let's work with this guy. 1 plus x to the power 4 over 9. Right, that's the value we found of dy over dx squared. So just placing that there now, right? And I hope this is making sense, guys. So from that point, we basically just simplify this whole thing, and then let's just bring this out. Let's like exclude that for the moment. Now let's just look at this part now alone. So looking at this part alone, we're just gonna do this. That's basically 9 over 9, so it's basically just going to be 9 plus x to the power 4 over 9. That's the same thing. This is the same thing as that, you know. We're just trying to make it, simplify it just to make things easier. And then with the square root rule, we end up with something like this. 9 plus x to the power 4 over 3. Because basically this is the same as square root of the numerator and square root of the denominator, so that's how we end up with that on the denominator, the square root of the denominator gives you that. So now we have a much simpler expression now. Now we can bring it back to this guy. We can bring it back to these guys, you know, bring it back now, you know. So with that being said, let me bring this down a bit. With that being said, right? Now we have a being equals to 2, 0, 2 pi. Now we just have this multiplying x cubed over 9, multiplying square root of 9 plus x to the power 4 over 3 dx. Let's not forget that. Okay, so now we have a much simpler scenario going on here, so I mean, case going on. So now, you know, let's just break it down from this point, really. These two are going to multiply, right? So the numerator is going to multiply, the denominator is going to multiply. So let's just, for now, let's bring out like all the constants, you know, so we know what the hell's going on. So we just bring out 2 pi now. There's a ghost in here. X cubed multiplying 9 plus x to the power 4 over 9 times 3, which is 27. It's 27, right, on the denominator dx. That's a constant. So we could also bring that out in the next case. So our next, let me just so you guys don't lose track. This is where we are. This is where we are right now. So let's move on from there to here now. So A will now be, it's quite a lengthy process, hey, but I'm trying to make sure you get everything. So now we're going to bring out, you guys can't see, can you? Okay, so now we're going to bring out the 2 pi and the 27, because this is 1 over 27, that's another constant. So we're going to bring it out of that, and we're going to end up with 2 pi over 27. Now we just have a numerator things going on here now. So we're going to end up with x cubed times the square root of 9 plus x to the power 4 dx. I listen to a lot of rap, and I'm sorry to say this, but this is something I can definitely fuck with in terms of integration. Okay, I'm sorry to be playing around, but yeah, you know, now this is actually something we could, you know, do and deal with, you know, like we can integrate this, because if we let that be equals to u, the 9 plus x to the power 4, we could actually integrate this, okay? So this is what we have now. This is our latest, from all the way up here, from all this, right? We found all the important values. We found out dy over dx, then we found out dy over dx squared. Then we placed that into that function, and then we simplified from there, and we ended up with that. And then we brought it back into the same expression, Then we simplified within the expression, and we ended up with this. Brought out all the constants, and then eventually we ended up with a nice smooth thing like that. So from this point, we could just shoot straight to integration now. I don't know if I have enough space. Is this even enough? Okay, let me just do the let u stuff. Be on this side. I'll take everything from there. So let u be equals to 9 plus x to the power 4, right? That means du over dx will now become 4x to the power 3. You see what's going on? So now we can actually work something along there. So that means du over 4 is now equals to x to the power 3 dx. You see? Now we can substitute x to the power 3 dx, x to the power 3 dx. We can substitute that now for du over 4. Okay, that makes sense. Now this is actually something this is a very important thing. This is key right here. So we can substitute that that as du over 4. Now we remember our u now is 9 plus x to the power 4, right? So now we could just shoot ahead